Okay, this is part 3. This is the third part of our program. So we've got our reversing. Now we're going to have a little look at the binary. So we're going to see how we can convert an integer into binary. So that could be quite interesting. Now, if you haven't done that before, there is a feature in Python. It's called a function called bin, and we can type it over here. If we put bin and put let's put a number we know in. So 3 should be, what's the binary equivalent of 3? Let you work that out in your heads. Hit enter, and it says 0B11. So 11 is 3 in binary. If we do bin, let's do 255. That's a nice big number there. And that should be 1, 2, 3, 4, 5, 6, 7, 8 ones there. That's 255 in binary. Bin 0 should be binary 0. Okay, then we got the speech marks tell us that this is a string, which is great. We can manipulate a string, but we've got this O and a B at the start. Now that is a code to tell the computer that it's looking at binary. So OX will be there, will stand for hex. That means binary. So what we need to do now is strip that off. So we're going to do some string slicing again. So we're going to have a little think about how we might do some string slicing on that, what that might look like. So let's try again. Let's do bin 255 and let's just think about what can our string slicing be. We need the first 2 gone, so we need everything from the second character onwards. So that should work. And here we go. So we've sliced a string using this system here. So that's the starting point. The end you leave blank because it's going all the way to the end, and it's taken all of that through. That's a big number. Let's just try it with bin 3, just to make sure we got it right. So I can't quite count all those ones on that little screen. Whoop, done something wrong there. Bin 3, and then put that in a bracket, 2 colon, and here, and there we go, 1 1. That's what we wanted to see. That's the same as it was up here with the OB gone. So we've got that working. So we've got this binary thing to use. So that's fantastic. So now let's try and write our program. Now I like this. We can use this this data thing. So let's maybe take that and put that into a function and use it later. So let's take the first line out because we can put anything into it. Let's call it def reverse and give it some data, and then we'll use that in our code and tab that in so it's all lined up nicely. But what I don't want to do, I don't want to print true. I want to return the Boolean true. This is more common in computing. We want the function to, we give it some data and return true if it's correct and false if it's incorrect. So we can return false. We've got a function there. Fantastic. So we can try and use that actually. So if we do if we do reverse and give it a number, remember we're doing it as a string, so 1, 2, 3, 4, 5. We want to print the outcome, don't we? So print whatever it returns back. It's going to return back a Boolean. And run that, and that's come back as false. We don't need to print in there because we know it works. That's just using up processing power. There we go. That's palindrome, and that's printed true. So that's working. So fantastic. Let's delete that. Right. So we worked out before that we've got some storage in our program, and we want to store these palindromes as we find them. So they're double base palindromes. So I'm going to put double base palindrome here at the top, and this is going to be somewhere where I'm going to store all the ones that I find. I'll probably do it in a 2D array because I can store the integer and the binary together as a little pair. They can go in there. Let's close that down. Have a look at that in a moment. Okay, so we need that. We also need to be able to count how many we find. So let's put a variable called found. Make that 0. Every time we find one, we can add to that. And once we get to 20, we could stop searching. So that could be the control for our loop. So we could have a while found is not equal to 20 loop going on. and all our code could be down here. And if you find one, we could add one to found, so the found could be counted, and then it will stop at 20. We also need to give it an input, and our input's going to come from a number, which I thought maybe we'd use the word number count as a variable. Number start with number 1, check that, then check 2, then check 3, and so on. So now we're starting to build up a little bit of code here. So we have got the start. What we're going to do next. So we've got a number, we've got a count. So let's see. I'm going to call it my base 10 palindrome. Now, is it a base 10 palindrome? And we're going to go to our reverse function we created, and we're going to give it the string of the value count. Now that should return a true or a false, but it's not going to work as it is. And I've got this red underline. I've just realised why. All my function is down here, but in coding, you put your functions first, don't you? And let's put it there. So it won't be able to use it until it's seen it and knows it exists. So the reverse function's there. So this is called a user-defined function, something I've defined myself. I've created it, and we can use it further on our code. So reverse string count, and if that is true, so if it's a long variable name, but we know what it means now because we're using it. So if base 10 palindrome, if it's true that it is a base 10 palindrome, next thing we want to do is find the binary and check that. So let's just say the binary value is equal, remember what we did before, so we'll do the bin of count. So count's 1 start, we'll do the binary of count, but we'll strip off that 0b at the start, put a 2 colon there. So now we've got this binary value, and let's check that. Let's just send that into our reverse function, see what it comes back with. So let's just do another thing, base 10 base 2 palindrome this time, equals reverse, and we've got to give it we can just give it binary, because binary is a string already. We know that was a string before, so we'll just give it binary, and same thing there. So if that is true, so if base 2 palindrome is true, then we could take the base 10 value and the base 2 value, and we can stick it up here in that list as a 2D array. So what I can do then is just do the double base palindrome dot append. So we're adding that to the list. That's a list method, and in there, square brackets. Let's just move that over, and we want to put in the count, which starts off as 1, as we know, and we also want to give it the binary value. Now, once that's done there, we know we've found one, so let's increment found. So found equals found plus 1, and then whatever happens, we want to increment count. So we increment count outside of that if statement. So in the loop, we're going to do all this. If it's a base 10 palindrome, brilliant. Let's check the binary. If that's great, that's right, that's great. Then we found one. Either way, if we do or we don't, we're still going to increment count by 1, and then the count value. Then we're going to test 2 the next time. We're going to test 3. We're just going to keep going and keep going and keep going until we found 20. And because found gets incremented here, as soon as found gets to 20, this whole loop will stop. And at the end, we can print that and see what it gives us. So you have a play with that. Remember, you can pause this video at any time. So we just want to print. Let's just print double base palindrome. Should have an S on it, really, shouldn't it? The plurals, yeah. Just make sure you check my changes when you do something like that. Wow. Oh, I've done that in a loop. Okay, let's stop there. Okay, I don't want to crash Repl.it. Now let's try it. Because the loop when it's got to 20. There we go. So 1 1 3 1 1, and we can look down. That's a big number there, 1758571. So that is that's 1,758,571. This is a big number there. It's a binary equivalent. So we've got those 20. Took a little bit of time to do. That looks good. We can just show you something you may or may not have seen now. Let's just tidy that up in terms of printing. And I'm going to just show you how to do some print formatting here. So let's loop through the list and print them pair by pair in a nice format. So for pair in double-based palindromes, so for each pair in there, so it's going to loop through, take the pair. Each pair there's 2 items, so it's going to be a list. See, it's a 2D array, and we've got this is position 0, 1, position 0, 1, each of those items. And I've called that little pair, I've called it the variable name pair here in the loop. So I'm going to print, and then just put in the brackets, just put pair 0 and a comma, and I'll put pair 1. Let's have a look and see what that looks like. Let's get rid of that line there. It's going to loop through, and processing time. See, there we go. It will appear there. Doesn't look great. Let's just try and use the word "and" in there. See what that looks like. Okay, a little bit better, but I'd like to align these, but we can't do it for printing like this. I'm going to show you something else. It's the using the F formatting in print. So this time, just see how I form this out. So let's just write underneath, and I'll delete it after. Print F, and then just use speech marks here. I'll put the 2 in already, and we're going to use curly brackets. And then for formatting, it reads the curly brackets and does something with it. So we're going to print pair 0 and then put a colon, and the colon tells it what to do with it afterwards. And we're going to give that, it's got 7 digits as the maximum, so we're going to give it 7 digits. And this arrowhead here is saying justify it to the right hand side. Then we'll put in the word and this time I'm going to give that 5 character spaces for the word and, but center that by using the hat here. So it's going to center it within 5 characters, so it'll end up being space and space. Then after that we can do pair 1, and then we'll give that, it's quite a lot there, so let's try 24 characters, and we should have the final speech marks in the bracket there, so don't need this line. Fingers crossed, print that. And we should see some justification. Here we go, so it's all nicely lined up for us. So we've given 7 characters over to this, and we've right justified, so it's come to this side, and we've right justified that. And just to show you what that means, if you just turn that arrow around the other way, you'll see the difference coming over here. While that's loading, we'll also write here this bit in, which is print. These are the first 20 double base palindromes, and then underneath that, give the screen a bit more space, and then just make it a little bit neater. In a load of equal signs there, just to tie that up a bit, and I'll duplicate that line at the bottom, run my code, and I should have a nice neat little table there coming through. Excellent. Okay, and there they are. We can see they're correct. If you just want to test it, see if we can get any more, we could do 25, but that's going to probably take ages now because you've got, what was it, 1.7 million for the first one to get the next 5. The processing power each time, it's got to run through another huge amount of numbers. In fact, it might take 10 or 15 minutes, so maybe that wasn't such a great idea, but I'll just wait another minute to see if that works. So there we go. So that one went down to 5 and a bit million, so it's tested that many more to do it. So there you go. You can run your program, you can make some changes, you could change some values in here and see what it comes up with. You can maybe change the binary to oct, so we can use oct as well. That's a base 8, and yeah, hopefully yours works. So like I said before, hopefully you stopped and paused along the way and tried it out for yourself. If not, you can still learn by seeing how people do things. If that's giving you some ideas about how to do better on the ones you did last week, then maybe use that to go back over and try those out. Okay, brilliant.